Hi, I'm Christoph from Berlin, Germany, and I work for KDAB. And in this series, I am talking about how to speed up your day-to-day development life on embedded. In this particular video, we are going to talk about containers in embedded. Today, I will show you Torizon from Toradex, which is one way to use containers on embedded. So let me tell you more. In recent years, shipping all dependencies for a product became quite hard. Products became more complex in usage of external libraries. They became more connected to other applications or the cloud. Programming libraries and languages have a faster release time cycle and less stable APIs and ABIs right now. This is called dependency hell. Because no distro can ship all of these libs, not all of these versions, embedded engineers are almost always required to ship everything themselves. Because also project internally, there are combinations that work together well, the right mix must be shipped. This forced engineers to almost always ship their own fully fledged distribution, maintaining BSP, and imagine all the work this entails just for security updates alone. In addition, maintenance mechanisms such as over-the-air updates, low-level boot-up settings needed to be developed and maintained as well. To react to this fact, containers can be a solution. Before, software engineers needed to maintain the whole operating system with only little BSP help from the vendors to adapt them to the underlying hardware. Now, the hardware vendor builds and maintains a Linux BSP, which they often did before, that acts as a container host. Software engineers only ship their containers containing their specific app library combination on top, bundling a combination of executables, libraries, and system settings all in one package. This is now the container. Application containers can easily be exchanged, and thus updates become easier and safer to handle. In this little demo, you see a ship dashboard application running on embedded hardware, in this case an iMix 6 Quad Max. What you cannot see is that internally it runs on Torizon, a container solution by our partner Toradex. So actually there's a base container running on the iMix 8 hardware, abstracting all the hardware specifics. On top there's a container running a Qt application, and without reboot I can maintain, organize, stop and restart many containers on the system. See how I can start another container without rebooting, now running a Slint application which is based on Rust. In each of these cases, all settings and libraries for the specific programming language were bundled in a container which runs on the same base platform. For the device preparation, it is very easy to install the Torizon platform containers from the web using the Toradex Easy Installer, also known as TC. When connected to the internet, a fresh Toradex board always offers to install TC. After this, the container-based platform is already installed and we are ready to deploy our application containers onto the system. Of course, you can also just install Docker in a regular Yocto platform to simulate all of this on your other board. To create all of these application containers that now run on top of the base container that we just installed on the device, preparing the device, we use Docker files. Toradex provides two different kinds of Docker containers to build upon. The first one is called the build container. So what we do here is we are actually importing, cloning the build container onto our system, and then install all the required development packages that we will need to install our specific application. In this case, it's a Qt application, so we can see Qt Declarative, for example, is installed on the system. Then, obviously, we need to get our code into this build container. For this, we say add, unzip it, and also just put it inside. The last step on the build container, or second to last step, is to actually build the application. So what we do is we are running cmake make, and this actually builds our application inside the build container. The build container is a cross-build container. That means it can produce software that is intended to run on our hardware. Then there's a second container, which is called the run container. This is the container that is actually running on top of the Torizon system. What we do is first we pull it, and then we install all the runtime libraries that are the libraries that are needed to run our application while it's on the hardware. So you can see here we are installing virtual keyboard, quick controls, and charts, which are needed. And then, most importantly, we take the application that we just built in the build container and move it to the run container. Then we configure some settings which are important to run our applications and set our run command. In the end, we've built this run container, which we can then push to some registry and later pull onto our hardware to be used and run there. Okay, now that we have seen the Docker file from the internals, we can actually build the Docker file. I just run docker build, give it a tag qt ship demo, and this will now do all of these compilations that I've told you about. So first configure the build container, use the build container to cross-compile, and then configure the run container. Now everything is successfully built and tagged, as you can see, and I can push this image to Docker Hub in this case. So I write docker push qt ship demo, and everything will be pushed to Docker Hub. Now that we have pushed our image to Docker Hub or any other registry, we can actually go to our device and look how images are maintained on the device. For this, I just entered the URL of my device and I'm greeted with a Torizon login page. After entering the credentials, I will see a web UI where I can manage all my containers. Containers are organized in stacks, and stacks are organized for themselves in environments. I click on the primary environment and I see this environment now has 4 different stacks. I can see most of these stacks are inactive. The only stack that is active is the Torizon stack, which is the base of all the system. To start an application or to inspect it, I can click on one of the stacks. I see this is the Qt stack, and the Qt stack can be edited with a web editor. This web editor is a Docker Compose file that you can edit online to configure which image to pull and to use in this application, and also all the other settings. For example, which resources need to be pushed from the base container to your application container. You can see that I'm using the image that I just created, which is then pulled from the internet. And also you can see that many resources from the main system, for example, the temp directories, the devices, the udev, so that's for mouse input, are shared with my application container. I could now update this stack, but this is already configured for me, so I can go back and start this stack. And as you can see, the application is now running on my demo device. I can go ahead, stop this stack, and without restarting the device or doing anything, I can just go in another stack, which is now, for example, the Slint stack, and I can start this other stack, and you can see the application starts again, and this application is now not a Qt application anymore, but is now the application that was built for the Slint container. So you can see one system without a reboot, 2 different programming languages and settings, all bundled together. And as you can also see, the update coming from the cloud makes it really easy to deploy and iterate on your software. Let's talk about the pros and cons of this container-based approach. The advantage that comes first is you only need to care about your app and the interface to the container host. Your surface of work is much smaller. Security updates are often not your problem, but the problem of the vendor. And container host has a mechanism to update built-in stuff. Fleet management is possible inside the host. Second advantage is containers are very suitable for updates. In production and initial deployment can be done more easily with containers, and you might only update the app and the container host always stays the same. Also think of the new EU regulations for device lifetime long updates. The third advantage is during development. Embedded containers can be emulated on desktop. Advantage number 4, it's based on known Debian Linux systems with a package manager that you know. You only install packages and dependencies like on a Linux desktop. Now come to the cons of this approach. One disadvantage is the learning curve, which is not steep but contains lots of technology and is a rather long way to go. For a quick installation, you're bound to the packages that are currently available in this container or the others you have to build. When it comes to cost, Torizon can cost fees. A subscription is forwarded to the customer's customer for the hardware per time and per device. In comparison with the classic embedded approach, you cannot fully adapt or modify device software. Lastly, updates are bound to a container registry infrastructure. That means maintenance cost, and it's not for free. Your only method of deployment is the cloud. Overall, using containers is a good option to consider, especially when knowledge about the hardware and BSP work is low in your team and you want to concentrate on your application development only. In conclusion, containers help with bundling. They allow for updates and deployment on your machines. It depends on your business structure, budget, prior knowledge about containers, if it's right for you. For me, it stands at the same level alternative as Yocto or distro images. You have to find out what's right, but we can help you with a decision or evaluation. If you have further need in help for Torizon or Yocto, we have the experts in our team and stand by your sides to deploy and update your devices. Thanks for watching this tutorial. Today I showed you containers only using the example of Torizon, but more vendors offer them and you can also run them on your own. If you want to learn more, let us know. You can also watch the other videos from the series where I talk about embedded development. Auf Wiedersehen and see you in the next video.